Good day, guys. Welcome to um, this class. This is a continuation of our class on atomic physics, and today we're going to be looking at the models of the atom. Models of the atom. Okay, so in our previous video, in our previous class, we introduced the concept of the atom. So today we're looking at the models of the atom. Okay, so I hope you have your writing materials ready and you are ready for the class. This is Nobleman Science Tutor Sublime. I remove your online tutor, and this is your physics video tutorial. Okay, so if it's your first time or visiting this channel, this is a channel where physics is broken down to an understandable level. So it is meant for all students, all science students, and those, especially those who are finding physics difficult to understand. So if you are here for the first time and you love science, you love physics, this is the right place for you. Okay, so if you have not subscribed, please subscribe to this channel, click on the notification bell so that whenever we upload a new video, YouTube will notify you. You can reach us through the WhatsApp number that is showing right on your screen. Okay, so my name is Otobo Michael and you are welcome to this class. So if you are ready, let's go straight to our class, models of the atom. That's what we are discussing today. Okay, so let's go. So as I said, we are looking at the models of the atom, and in this particular class we are going to look at different models. So we're looking at about 4 models of the atom. Yes, about 4 models of the atom, and each of these models, they were postulated by different scientists. Okay, they were postulated or propounded by different scientists. So the first one we'll be looking at is the Dalton's atomic model. Okay, or what you call Dalton's atomic theory. Okay, so Dalton generally is credited as the father of atomic theory. So in your chemistry class, before you study anything about atoms, you must mention Dalton. So John Dalton is generally known as the father of atomic theory. And what was his postulation? Now, most of the postulation that Dalton made, they had different modifications later on, um, as a result of different discoveries that now came up after he postulated or he made his theory. Is that okay? So different modifications came up, and then Dalton's theory was actually modified. Okay, so we are looking at the Dalton's atomic theory and then some of the modifications that arose from different experiments by different individuals. You know, one thing about science, that science is dynamic, and from time to time there are new discoveries, and that was what actually happened to Dalton's atomic theory. Okay, so the first postulate of Dalton's atomic theory, and it says that matter is made up of small indivisible particles called atoms. Okay, so that was actually the first postulate of Dalton's atomic theory, that matter is made up of small indivisible particles called atoms. So what he said was that the particles are made of the atom cannot be divided. Yes, they cannot be divided, but other scientists made experiments like Sir Rutherford. His own experiments show that atoms can no longer be regarded as being indivisible. Okay, so Rutherford actually discovered that atoms are made up of 3 main subatomic particles, namely the protons, subatomic particles, namely the protons, the neutrons, and the electrons. Okay, so this is the modification to this first postulate of Dalton's atomic theory. So atom is made up of 3 subatomic particles, not that it is indivisible. So that is one. Then the second one is atoms cannot be created nor destroyed. Now this discovery was actually modified again when Henri Becquerel showed that atoms can be disintegrated to form different elements, and the discovery of radioactivity modified this Dalton's atomic postulation. All right. Then the third postulation is that the atoms of the same element are alike in every aspect and differ from atoms of other elements. Right. Now, the discovery of isotopes contradicted this. Isotopes show that all atoms of an element are not exactly alike in all aspects. Okay, so this is another modification to the Dalton's atomic theory. And another modification, atoms of different elements can combine in simple whole number ratio to form compounds. But discovery of organic compounds shows that atoms can actually combine in large whole number ratios. Large whole number ratios. So these are Dalton's atomic theory, and then the modifications to the Dalton's atomic theory. Okay, so please take note of this, and then especially the modifications, because this is a typical examination question. Yes, you can be asked what are the modifications to Dalton, or state Dalton's atomic theory, and then the modifications to the postulations. So you should be able to study the theory and study the modification. Okay, yes, because we're in the era of modern physics and modern technology. Okay, so this is Dalton's atomic theory. We're looking at another model now. So still on the model of atom, we have J.J. Thomson's atomic model. So another person that discovered atomic model is J.J. Thomson, and J.J. Thomson proposed that an atom consists of homogeneous spheres of positive charge, inside of which are embedded negatively charged electrons. Okay, so what this man just proposed is that atom has homogeneous spheres of positive charge, inside of which are embedded negatively charged electrons. So that the electrons, they are in an atom. Okay, so this is J.J. Thomson atomic model. Another atomic model that is very, very key and important is Rutherford atomic model. So Rutherford actually proposed a planetary model of the atom with the following assumption. So this is Rutherford's proposed atomic model. Okay, so Rutherford proposed something that looks like the planets revolving around a central nucleus. So, and then the electrons, they are on the orbit. So you can see the electrons here orbiting around the central nucleus that contains proton and neutrons. So these are electrons that are orbiting around. So Rutherford model is like the planets revolving around the sun. Okay, so the nucleus is like the sun, then the planets are revolving around it. That is what Rutherford proposed, and then these are some of his assumptions. One, proton with positive charge are concentrated in a small nucleus. Okay, so you can see the protons in this small nucleus here. Then the nucleus is centrally located in an atom. That's exactly what you are seeing here. The electrons are located at the peripheral of the nucleus, and they render the atom electrically neutral. Okay, so in our previous class, we discussed this electrical neutrality of the atom. And what we said was that because the nucleus is positively charged, and the electrons on the orbit or on the shells, they are negatively charged, and also because the charge on the nucleus is equal to the charge on the electron, but opposite in sign, that one makes the electron to be electrically neutral, because the negative charge on the electron cancels out the positive charge on the nucleus. Okay, so that is what makes the atom to be electrically neutral. And another postulation of this theory is that electrons revolve around the nucleus of the atom. Okay, so that's what I just discussed before. The electrons revolve around the nucleus of the atom. Another one is that there is a wide gap between the nucleus and its orbiting electrons. So these are some of the postulates of Sir Rutherford. Now, these postulates had some limitations. What are the limitations? One, this postulate, it predicts that light of a continuous range of frequency will be emitted, whereas modern experiment reveals line spectra instead of continuous spectra. Okay, then Rutherford stated that atoms are unstable. Electrons quickly spiral into the nucleus, but generally atoms are stable. So these are the two limitations of the Rutherford's atomic model. So those are some of the limitations of Rutherford's atomic model. Alright, so you need to take note of all this. Another model of the atom that is very, very important that we need to take note of is the Bohr's model. The Bohr's atomic model. Niels Bohr was a Danish scientist, and he suggested the model of the atom, and he says that the electron occupies fixed orbit around the nucleus of an atom. So this is his model. This is Bohr's model of the atom. Okay, so he says that the electron occupies fixed orbits around the central nucleus. Now, he also says that when an electron is in one of its orbits, it does not radiate or emit energy. So what it simply states is that the electrons in the orbit, they are stable. Yes, the electrons are stable, unlike what Rutherford said. He says that the electrons, they are stable in their orbits. And he also states that the energy of an electron in an atom is quantized. That is, it has discrete values. Okay, so the energy of the atom, or the energy of an electron in an atom, has a discrete value, and it is quantized. In fact, it is from this Bohr's model of atom that we have energy quantization. Okay, he was the first person that mentioned quantum of energy. Okay, so another suggestion that this model gave was that when an electron jumps from a higher energy level to a lower energy level, that is, assuming an atom is in this energy level, so assuming it was in this energy level, this is high energy 1, then this is a lower energy level, this say, okay, let me just say, okay, this energy low. So if an electron moves from this energy level, so this is an electron, if it moves to this energy level, okay, what it says that this electron emits an amount of radiation or quanta of energy. So an electron emits a photon. This quanta of energy is called photon. Photon is like packet of energy. So a photon is a quanta of energy of light when an electron jumps from a high energy level to a lower energy level. Okay, so a photon is the energy emitted in form of quanta when an electron moves from a higher energy level to a lower energy level. And also, when an electron absorbs energy, or when it absorbs radiation, it becomes excited, and it can move from a lower energy level to a higher energy level. Okay, so when an electron absorbs quanta of energy, it becomes excited, and it can move from a lower energy level to a higher energy level, as the case may be. Okay, so the energy emitted or absorbed by an electron is given by this equation, where you have that EU is the energy at the upper level and EI is energy at the lower level, and F is frequency, then H is Planck's constant. Planck constant has a value. Okay, Planck's constant has a value. So this is the quantity of energy emitted when an electron moves from a higher energy level to a lower energy level. Okay, so please take note of this and take note of the Bohr's model of atom. Now, what are some of the successes of this Bohr's model of atom? 1. Bohr's model was a success in calculating the radius of Allard orbit and the total energy of the electron in each Allard orbit of a hydrogen atom. It was also a success in predicting the spectral line of glowing hydrogen atom. It was successful in explaining the quantized energy state of photon in photoelectric effects. So Bohr's model actually had some successes, but it also had some limitations. 1. It could not explain bright spectral line of complex atoms like oxygen. 2. It viewed electrons as particles moving around the nucleus at definite orbits. Then 3. Experiments have shown that electrons can behave like waves or particles. Okay, so these are some of the limitations of Bohr's model. Alright, so let's look at another model of the atom. This is electron cloud atomic model. So I think this should be the last model that we're going to look at. Electron cloud atomic model. So this model actually visualizes that an atom consists of positively charged nucleus surrounded by electrons in a cloud of different energy levels. So this is the electron cloud. Okay, electron cloud of different energy levels that are surrounding the nucleus. The location of electron depends on how much energy electron possesses. So what he's saying is that the higher the electrons from the nucleus, the higher the energy the electron possesses. So electrons with the lowest energy are found in an energy level close to the nucleus, while those with the highest energy level are found on the atom's energy levels further from the nucleus. Okay, so these are his postulation. And then another one is that the electrons change from one energy level to another energy level depending whether they gain or lose energy. So if you look at this model, you find out that this model actually is just like an extension of the Bohr's model. Okay, it's an extension of the Bohr's model, but this time this person is saying that the electrons, they are like in a cloud. They are like in a cloud. Okay, so this is a cloud atomic model. This is a cloud atomic model. Okay, so or the electron cloud model. So these are some of the models of the atom. Each of the models, they have explained the atom in different lights, and this is what actually gave birth to what we have today as modern physics. Okay, so guys, thank you so much. This is where we are drawing the curtain for this lecture. I hope you have enjoyed this topic, and we hope to see you in our another class. But before we leave, please subscribe to our channel, give us a like, give us a positive give us a positive comment, give us a thumbs up, click on the notification bell so that when we upload a new video, YouTube will notify you, right? Also, you can reach us through the WhatsApp number that is showing right on your screen. Okay, so I wish you the best, and hope to see you in our next class. Okay, so thank you so much for your time. See you.